Okay, so how's everybody doing today? Sleepy, some of you. All right, so before we start today, does anybody have any questions for me that the rest of the class might like to hear the question and or the answer? Yep. Format of the midterm. The midterm will be a series of multiple choice Scantron questions. Yes? Nope, the final will also be a series of multiple choice Scantron questions. You will see a sample midterm before the midterm, so you have some idea what kinds of questions there are. For the final, I don't think you'll see a sample final, but you'll have already seen your midterm and the sample midterm, and it's the same idea. It'll just cover stuff from the second half of the course as well. Okay, good. So what we did so far in the first 2 weeks of this course was to really learn very quickly the basics of Python, which are similar to the basics of many programming languages. We're lucky that Python is the kind of language that really in a few weeks we can grasp all of this without too much difficulty. And so we can very quickly get up and running. So what I want to do this week is take a break from learning new things and just revisit what we've been doing and how we can use it, because now you basically know how to program. If you've done a reasonable job on assignments 1 and 2, then you're now beginner programmers. You can write any program now. So I want us to take a step back and use all of these things that we've learned. So these assignments so far were really just write a function that does this, write a function that does that, write another function that does this. So what I'd like to do now is really write a program. So that's really a collection of functions that together do something, or a collection of logic that does something. And I think the nice way to do this is by writing a few games. So this class and next, we'll write some simple text-based games in class. And your assignment then will be to do something similar, your assignment 3, something similar yourselves, and submit it. So this is a super open-ended assignment. And right now it may seem extremely daunting. Hopefully after this lecture it won't seem so crazy. And after next lecture you'll see we can actually, even in the space of one class, you can do a fairly interesting game. But what you can do in the meantime is to start thinking about, well, what kind of game can I make in a terminal like this that I have a chance of making and finishing in the space of a week, because it's due again on Monday morning. Okay, so keep that in mind as we do things today. And now this will also be the first time any of you write what is a standalone program. And these are fairly small things. Of course, these are things that we can do, should be able to, a single person can write in the space of a week. But for many of you, this will be somehow the biggest thing you've ever written, because for some of you, the first thing you ever wrote was 2 weeks ago. So we're gonna, I'll try and sort of very informally also present to you some software engineering skills. And these are skills that are typically associated with writing big programs. And big can mean different things, can mean like hundreds of lines of code, or thousands of lines of code, or tens of thousands, or even more than 1 million lines of code. But and there's a whole field of study, software engineering, how to manage these kinds of things. So I'll be talking about a very minimalist approach to this, And the fundamental thing that I want you to do while making this game, and probably while working on software projects for the next little while, is to always try and have something that is currently working. Okay? So you start with nothing, and you have this vision of the game that I want to make. And I would like to get you from nothing to that game that you want to make, but at all the steps in between, I want you to have something that's working. Okay? So, when you're only partway there, it won't be the complete game, and it won't do everything, and it won't have every feature that you were hoping for, but it should be something that's working. So always writing a little bit, stopping, testing, making sure everything is working, and once you've done that, say, okay, what's the next thing that I need to do? And we'll think of this as kind of adding features as we go. You start with a program that does nothing, you have a program that should do all of these things, and let's add one feature at a time as we go, each time checking to see that that feature works and that we always have something that's working. Because what I can tell you, even something like writing a small game, if you start with nothing and all you do is write and then you try and run it, for sure it's not going to work, and it's going to be probably have several mistakes in it, and those things may interact in weird ways, and it's going to be very hard to chase them all down. So let's move slowly, which is what I'll do in this course as I teach, and I'll ask you guys for help. Okay. So today I'm hoping that we can write 2 games in the space of this class, and the first one is a very simple one. You've probably seen it before or had someone do it to you. Play this game with you before. It doesn't have to be a computer game, but it's kind of nice and easy if it is. So here's the game. The computer is going to pick a number, an integer, between 1 and 1,000 inclusive. And it's going to ask you to guess that thing. It's not going to tell you what that integer is. It's going to ask you to guess it. You'll get 10 guesses. And each time you guess, this computer is going to say, either your guess is correct, if you guess correctly, and then the game should end and it should say, congratulations, you win. Or if your guess is incorrect, it'll tell you whether your guess was too high or whether your guess was too low. Okay? Simple guessing game. So that's the thing we want. Our end goal is to have this program. Starts up, the computer says, I'm thinking of a number between 1 and 1,000. What do you think it is? You have 10 guesses left. And then you enter a guess, and it tells you high, low, whatever. This happens for up to 10 rounds, and then the thing says, sorry, you didn't guess it, you lose. Or it says, somewhere along the way it stops and says, congratulations, you guessed it right. Okay? All right. So change to the right folder. And today is the 21st. And let's call this thing guessing.py. Okay. So for my description of this thing, of this game, what is the first thing that this program should do? Yeah? Yeah, it should pick one of these, it should pick this number between 1 and 1,000. And although this doesn't sound like the most exciting game, and once you've played it a couple of times, you'll know that you can always win it, there's a chance that you might want to play it more than once. Or maybe you watch someone else play it and then you want to play it. So in particular, the computer, the game, should not pick the same number every time. We could hard code it and say, all right, the computer is going to pick 752, and every time it's going to be that. But once you play it once, then you kind of figure out what's happening. Actually, probably once you play it twice, you'll figure out what happened. So what we want is some way for the computer to pick this random number, or this number that at least looks random, unpredictable in any case. So first we have to figure out how to do that. We haven't seen anything like that yet. So we do the standard thing. We go to the internet and we enter some keywords related to what we want. So Python, because we're programming in Python, and random, that's something we want. And as typically happens, one of the first things that comes up is the Python documentation for this thing called the random module, talking about generating pseudo-random numbers. So we can take a look at that. So you read this information about this module. It helps you pick random. It offers functions that pick random numbers. And if you browse through this, you'll find find many things. But one of the functions in there is rand range. Okay. There's two forms of it. It can take one argument, which is a positive integer, or it can take two arguments, in fact, or even three arguments, including a step. And this thing behaves just like the range method, the range function, which gives us sort of sequences of numbers. If you give it only one argument, it'll return n, let's say, or stop. It'll return the sequence of numbers 0, 1, 2, 3, 4, 5, up to stop minus 1. Okay? All right, so that sounds like the thing we want. Now, it's in the random module, so we should make sure we use that. So let's, at the top here, make sure we import random. So that gives us access to all of the things that module provides, provided that we prefix their name with random dot, whatever we want. All right, so we're supposed to pick one of these random numbers, x. So we'll use the rand range function. It should be between 1 and 1,000. So something like that. Is that going to give us what we want? So the rand range documentation, if you read it carefully, says it returns a number between 0 and, in this case, 999. That's not quite what we want, is it? We were hoping to play with the numbers 1 to 1,000. So, yeah. So there's two things we can do. We can say, let's take something in this range, because this will give us then a number between 1, that's what that first argument is, including 1, up to 1 less than the second argument, which is 1,001, so 1 less than that is 1,000. Or a shorter version of doing that, or effectively the same thing, is to take the number between 0 and 999 and just add 1 to it. Okay? All right. So now our program does something. We should test it. Make sure it's a working program. So Python guessing.py. It picked 158, picked 159, 342, 110, 938, 983, 196, 616. Looks like it's doing what it's supposed to do. All right. So then what's the next thing? What's the next feature we could add to this game? Or what's the next thing that's supposed to happen in this game? Yep. So it should prompt the user to enter a number. Okay, so let's do that. That is and maybe it should introduce the game, say something like, I'm thinking of a number between 1 and 1,000. Try to guess it. And let's test. Always making sure we have something that works. Enter my guess. I don't know, 678. And let's see. So far it's working. Our guess is entered in this variable called guess. Or is it? Okay, so what's the next thing that's supposed to happen in this game? Yep. Yeah. So we should be comparing the user's guess to the number that that this computer picked, or that the game picked. Okay. So a couple of things can happen. For example, if the user guessed less than the true value, then we should tell them so. Your guess is too low. Otherwise, they might have guessed bigger than the true value. Otherwise, their guess wasn't too low and it wasn't too high. They win. And always put lots of exclamation points because it makes the game more fun. So let's check to see if we still have a working program. Okay, it's thinking of a number between 1 and 1,000. Try to guess it. Well, I'm going to guess 42. So we got an error. So now we don't have a working program. We have to stop before we add any features and figure out what's wrong and how we can fix it. Yes?
I think when it's input, we're putting a string in, but right now we're comparing to integers, so we need to add the other brackets.
Yep. So if we look at when we were testing our last feature, which was reading a guess from the user, we did that, and then we saw that, yes, I entered 678, and that value of the guess variable was 678, but it's not the integer 678. We look really carefully, we see that it's been quoted, telling us that it's actually the string 678. So we kind of had a bug that we didn't notice in our last feature, which was this line here. Input reads input from the user, and well, input from the user is what the user types, and before they press enter, it's just a sequence of characters. If we want it to mean something else, then we have to convert it to that other thing, and so that's what we should do. And we've seen that if you give me a string and I want to convert it to an integer, I can just do that. Call the int function on the string. Yes?
Given an attribute error, module object has no attribute and rand range.
Rand range? I don't know. I mean, it's telling you that you loaded the random module and it doesn't see the rand range function there, but it's there in Python 3. That's what I'm using. And it's there even in earlier versions of Python. So I'm not sure what's up. Yeah?
This is the name exit on the font.
So what do you mean it says?
It says name error on if guess is less than X.
Okay, but the name X is defined here. I mean, I'm not sure what code you're running, but okay. So let's see if this fixes our bug. 42 is too low, it says, and that's probably right. 42 is pretty much near the front of the range. But let's test this a little more carefully by just putting in a little bit of extra code. So we'll sort of spoil the game, at least while we're testing it. And we'll just print the value of x so we know what we're dealing with. Forgot a parenthesis. Okay, so the actual value is 595. If I guess 500, it should tell me your guess is too low. Now the actual value is 169. If I guess 500, it should tell me your guess is too high, and indeed it does. And now the actual value is 140, so if I guess 140, it tells me I guessed correctly, and I win. Okay. So that feature now seems to be working. We have something that's working. Okay. Now it's actually a full-blown game. It's not a very interesting one, but it's something that resembles a game. You play it, and you either win or you lose. So what's the next feature we should add? Or if anybody has any questions about anything we've done so far, go ahead and ask me now. Yeah? Debug doesn't do anything. That's just a string that I provided that should be printed. And indeed, if I look at what's being output here, the string debug gets printed when I do this. It's just typically when I put something into a program that I don't want to leave there forever, I make it look ugly, large uppercase letters or something, so that at some point I notice it and say, hey, this game is really not going to be very fun if you tell them the answer before, so before you finish this thing, erase it. Yeah?
If in the guess equals 1, if you remove the int and put it where the outside statements are,
Yep. Yes, so I could say, here I could wrap this in an int, like so. But then I'd have to do it here as well. And why do it in two places when I can do it in one? And we'll see there's another good reason for not doing that a little bit later. And that has to do with taking input from users or taking input from networks or taking input from anywhere. Is you may get input that's not what you wanted it to be. And it's better if you do that in one place and deal with any problems there. If we convert this thing to int in more than one location, then we have two potential locations where that conversion could cause a problem. You were going to suggest what we should do next? Yeah? What? Yeah. So the game is supposed to last for 10 rounds, or you're supposed to get 10 guesses, and it's supposed to give you feedback. Right now it only lasts one round, which is not really interesting. So we need some way to make it last longer. So let's just hide this debug statement for a moment. Comment that out. So we would like to execute 10 times. So there's a few ways to do that. One of them is, if we know how many times we want to execute, then a for loop works well for us, right? So we can just say something like for I in range 10. That will execute 10 times. It'll execute with the values I equals 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. No, I don't like that. I'll leave that as is for now. So that's fine. But maybe we should also let the user know how many guesses they have left. Okay? So for that, we might want to do something a little bit fancier. So this for loop will execute with I 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We could be a little bit fancier and do something like, we could actually count from 10 down to 0, down to but not including 0, and count by minus ones. Okay. And let's take a look at what that does. From 10 down to 0, counting by minus ones. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So that'll give us a loop where the value of I takes on 10, 9, 8 down to 1, which means we can print something like, okay, guess now you have 10 guesses left. You have 9 guesses left. You have 8 guesses left, and so on. Okay. So let's do that. Okay, so now we put this thing in a loop. It says enter your guess, and let's be a little bit nicer and say you have this many guesses remaining. I. Okay. All right, so now we will allow the user to guess many times. Okay. I'm thinking of a number between 1 and 1,000. Try to guess it. 10 guesses remaining. What should I guess? Good guess. That's too low. What should I guess next? Yep. Good guess. Still too low. Now what? Too high. Yep. Still too high. 800. Too low. 825. You guys are getting lazy. Still too low. Still too low. Yep. 862. Too high. 2 guesses left. 855. Too low. 1 guess left. It's between 855 and 862, not inclusive. What? 857. Too low, and the game is over. Good try, but you didn't win. Okay, so the loop feature still seems to work, and as you see, it's kind of nice to have that counter counting down, telling you how many guesses you have left. It adds some element of suspense to the game. But the end of the game was kind of abrupt there, right? It just goes back to the prompt. So if you don't win, then probably you should print something like game over. And it depends whether you want to be mean or not, whether you say you win or maybe you say you lose, but I don't know, you could say something like, well, if your last guess was correct, then you will have, this should be true, guess will be equal to x. And if it's not correct, then guess should not be equal to x. So you can say something mean like, you lose. only a single exclamation point. Okay. All right, let's try it again. First guess. Too low. Next guess. 700. Still too low. And a bad guess to boot. Yep. Still too low. 900. Still too low. 999. Too high. Too low. Too low. Too high. 975. Still too high. You guessed correctly. That was extremely lucky. I would say well played, but it actually wasn't. Just, congratulations on your good luck, I guess. Okay, so one thing to note here is it's possible to win this game every time, but you have to make your guesses basically optimal to do that. And optimal guesses are those that split the range almost exactly in half. Sometimes you can't split the range almost exactly in half because there's an even number of integers in the range. So you have to, like the difference between on the first guess being 500 and 501, that's basically the same thing. But if you always take one of those two near the middle, that's almost right in the middle of the current range, then you'll always get it. And if you fail to do so, then it's very easy to miss it. So starting at 500 is the right strategy. The 700 was a bad guess because you knew then it was between 501 and 1,000. So 750 is the sweet spot in the middle there. So yeah. And in fact, we could play this game not even between just 1 and 1,000, but between 1 and 1,024 and still be guaranteed to win. But beyond that, we couldn't be sure to win every time. Okay, but our game is still not quite finished because let's put this extra information back in while we're testing. Okay, so now we know the answer is 880, so I might guess 500 on my first guess, and then I might guess 750, and then I might have a divine inspiration that says 880, and it says, yes, you guessed correctly, you win. And then it tells you, guess again, you have 7 guesses remaining. That's not really what we want from the game, right? It's over. You guessed correctly. It should be done now, right? So back here in the code, that means something more should happen in this else statement. You need to say something. And there's a few ways you can do this. So one thing, you can look at this and think of different ways of trying to fix this. But basically, we've created a loop here with this for loop that is supposed to execute 10 times. And that's kind of hard-coded. That decision of making it happen 10 times is when we started the loop. When we created this range, that was there. So we could rewrite that as a while loop that has a couple of conditions in it that test some counter, and then we'd have to increment some counter, and we'd also have to check if the current guess was correct. There's a bit of a controversial sort of shortcut for these things in most programming languages. When you're in a loop, And the loop's not really supposed to end yet, but for some reason you'd like it to end right now and not execute anymore. Well, there's a statement called break. And what break does is it breaks out of the innermost loop. So right now, this code has exactly one loop. They're not nested or anything. So this break statement will break us out of the for loop. It will immediately jump to the line of code that follows this loop. Okay? So let's get out of there now. Try that again. All right, 669 is the correct answer. All right, so 500 was too low. 700 is too high, but 669 is correct. You guessed correctly. You win. Game over. Okay? Good. All right. So there you go. In this first half of this class, we managed to create a game. Is it completely done? Should we test it a little bit more? Yeah. How do you increase the... This game, there's not much you can do. You could introduce some element of time where you have to make your guesses happen in a few seconds and assume the person's doesn't have a calculator on hand, so they have to do that math in their head. You could increase the range instead of 1 to 1,000, it could be 1 to 1 million, but unfortunately the playability of this game, just the idea of it, is not that exciting. Let's call it the binary search game, and once you know the trick, then yeah, okay, it may be a good exercise to do the mental arithmetic involved, but there's no real exciting strategy there. It's not going to expand your mind to play this over and over for many, many times. But I'm more interested in not so much making it more difficult just yet, but making sure that it really works. And now, imagine that I'm playing this game and I'm really excited because it's such an exciting game. So I start entering my guesses. Okay, 500, 750. Oh, and then I put something else in. Oh, I got too excited and I entered some letters instead of a number. And now it's not even game over. It's just game crashed. Okay. And so we see, read the error message. It says value error, invalid literal for int with base 10, 48 CD. That's something. But the real important thing is this is happening at line 13. It's showing us the line of code where this happens, and it's telling us calling int was a problem here, and that's because we asked to convert 48 CD into an int, and that doesn't look like an integer. Yeah. You could probably write such a thing, but I'm not sure that it would be the correct thing to do anyway. So if somebody enters something that has some integers and characters in it, you're probably just better off telling them, this doesn't look like an integer, enter something else. So we should figure out how to deal with that. And there's a lot of things we could do. So we did something somehow really dangerous here. We did an input, and then we straight away converted that to an int without even looking at it yet, just hoping that would convert to an int. And that's dangerous in some sense because, well, it can not be possible, in which case it crashes. Okay. So what I'd like to show you now is a way of dealing with these kinds of things that's available in Python and available in Java and C++, so it's not at all unique. But let me talk about the hard way and the easy way. So the hard way to deal with this would be not to convert this to an int right away. It would be instead to write some function that looks at the string and decides whether that thing can be converted to an integer without causing an error. Okay? And you could write such a thing, but that means you would basically be writing your own function to convert to an integer without actually doing the conversion. You would just be checking to see if it's possible, and that's full of, I mean, there's all kinds of things that can go wrong. There might be integers you didn't think of, or things that don't work, and so you should. So that's one possibility, and it's feasible, but it's a lot of work. Another one is to try and convert it to an int, and if that fails, then just say, sorry, that didn't work. Give me something else that I can convert to an int. Okay? And if we look at this message here, so right here is when things crashed, and we got this traceback telling us what's happening, and we got this thing that told us there's a value error. So what this is what's called a runtime crash. So it wasn't when we compiled the program. The program was actually executing, and something terrible went wrong. And this is called an exception, so a runtime exception. And the nice thing about exceptions is it's possible to handle them. So you do something called catching them. So let's take this process of reading an integer from the user, and let's wrap it up in a function that handles all the bad things that can happen. Okay. So we'll write a function called input_int. It'll take a prompt, and it'll do the following. Well, we can take it from here. And it's not going to print that message. It's just going to print the prompt. And it's going to use this exception handling mechanism, which works in Python like this and in most other languages. So it's called a try except or try catch mechanism. So whenever you have a piece of code that may crash because of bad input or something wrong in a file or something you don't have a ton of control over, you can wrap it in this thing called the try except clause. So you say, I'm going to try this code, and if something goes wrong, and the particular thing that I'm worried about going wrong is I'm worried about getting this value error. So if I get a value error, then I should do something else. So let's do the following. We'll try and just return this integer input. That may go wrong because it may not be possible to convert it to an integer, in which case, whatever happens, whatever we write here is going to be the code that executes. And there's a few things we could do in this case. So it depends how we want to treat the user. So if they enter something that's not an integer, then, well, we could be mean and treat that as, an invalid guess, and they lose a turn because of it. And so then the easy way to do that would be something like this. If they enter anything which cannot be converted to an integer, well, we'll treat that like they entered -1. And -1 is a completely useless guess in this game because it tells you nothing. Of course, the value is going to be bigger than -1, and it wastes your turn. That's an easy solution. So if we do that, now we're not going to use input here anymore. Oops, shouldn't have done that. So I want to call my newly created function input int. And okay, so if I enter 500, it tells me my guess is too high. If I enter x, y, z, it tells me my guess is too low. And it's telling me my guess is too low because it's treating it like -1. Now that's a little bit too mean because it's not even telling me what happened. So we can change the code a little bit, maybe give some feedback. Okay, your guess was 500, your guess was too high. If I guess x, y, x, your guess was -1, your guess was too low. So at least now the user sees what's going on, and they get punished for doing this. Okay? So now we have a game that is fairly solid. It handles bad input, whatever. I mean, you throw whatever you want at it, and it runs to completion. Okay. I would probably, if I was doing this myself, be a little bit nicer and maybe have a loop here that instead of just returning -1 would just ask the user again. So not waste their turn, just say, sorry, you mistyped something, guess again. But I'll leave that as an exercise for you guys to do. Okay. So any questions about this code? Yes? Yep. So, what do you mean not use it there? Oh, I'm using it down here. Now when I read the guess, instead of calling input and converting it to an int, I'm calling this function to do that for me. And that's the thing that will give me back -1 if things go wrong. Yeah. Okay, so the try, so this is, it's called exception handling, and it's called the try except mechanism, and it works like this. You have a piece of code which may crash, and usually it's reserved not because you wrote bugs in your code, but it's reserved for things like a user inputs something that you don't like or whatever. So you take that piece of code, that's this piece of code right here. This converting this input to an int was a dangerous thing. It might crash if the user gives us something that doesn't look like an int. So we wrap that in this try except wrapper. So the try warns us, okay, there's some code coming up here. It could be a whole block of code with many instructions, just indented like we always do for blocks of code. It says something may go wrong in this code, and if it does, then I'll tell you what's coming up as one or more except clauses which tell you what to do if one of those things goes wrong. Okay? And here I'm explicitly saying one of the things that could go wrong is a value error. How did I know it was a value error? Because I looked at this error message that I got earlier on. Well, I know because if I do something like this, I get a value error. So that's the thing I want to deal with. If I see a value error, then I'll return -1 instead of anything else. Okay? But I could have wrapped this in a while loop that said, while the value is -1, try again. Read from the user again. Yeah.
When I put in a number, then like a letter, it would say
Are you using Python 3? I don't know. And you're using input. Okay. I mean, I can't tell you without looking at the code, and I don't want to do that now. Okay. Any other questions? Okay. So there's game number 1. And this has most of the things that you would like for the assignment, except for any sort of level of difficulty. Let's start at least on another game. And the game I'm thinking of now is a word game. And like word games, there are many such games, word games, trivia games, we need some data. So the plan is the following. It's another one of these, well, it's almost a guessing game, but not quite as the same as this one. The computer is going to pick a word, or the way the user will see it looks the following way. The computer is going to give you a list of letters, and it's going to say, make a word with these letters. Okay? And then you have to arrange those letters using all of them to make a word. And if you do, then that's a win for you. And we'll see how far we get. But you can imagine designing a game around this where the number of letters gets bigger, gets longer and longer, so the words have to get longer and longer. Maybe you have, it keeps score, how many times you were able to successfully do this. I mean, you can add all kinds of features. But right now, let's work on the basic thing, which is just you're presented with some letters, and you have to rearrange them into a word. Okay. So the first issue then is, well, we're going to need a list of words. Well, we've seen that before in this class on my computer and on many computers, and now even in this Dropbox folder. There's a file called words. So I'll just put it right here so it's convenient into a file called words.txt. So let's call this word game. So first thing from the computer side, it wants to make a list of letters for you to turn into a word. Now, we can't just do like we did before and pick some random letters, because there's a very good chance that you can't make any words out of those letters, which isn't really a very fair game. So what we'll do instead is we'll load up this dictionary, and we'll pick a word from the dictionary and then scramble its letters. So we know that there's at least one correct answer. Okay. So for that, we're going to do the following. Say words is equal to open. We open this file, words.txt. We read the whole thing, and we split it up into lines. Okay, so let's see that we have working code. Split lines. And that's why we check that we have working code all the time, because very often we don't. All right, so now we've got a list of words, 102,000 of them roughly. Let's take a look at that list. Not all 102,000 of them. Let's take a look at the first 50 ones. Okay, so there's the first 50 words in that list. Do you see any problems with using some of these words in this kind of guessing game? Yes? There's what? Well, that's okay. I mean, that's fine. Yeah. Yes, yeah. So there's some apostrophes. That's kind of it's kind of boring. Usually, if there's an apostrophe and an S, you know where those two are going to go anyway. And it's kind of weird. It's not really a letter. So maybe we don't want any of those words that have apostrophes in them. So let's filter those out. And we've seen how to do that. So we have a list of all the words that we got from this file. Let's get rid of the ones that have apostrophes. So we're going to make a new list where we take any word if the apostrophe is not in the word. Okay? So this is this list comprehension mechanism that I showed you. We'll take every word that's in that list, words, but only if the apostrophe is not in the word. Okay. Let's try that. Okay, so the words with apostrophes are now gone. So AOLs, AMDs, A apostrophes. Do you see any other problems? Yeah. There's single letter words. Any other in addition to that? So single letter words is not so good. Let's maybe get rid of those first. So that's another thing. We can just go through our list again and get rid of anything that's only single letters. In fact, even two-letter words are kind of boring, right? So let's only keep the ones if the length of the word is bigger than or equal to 3. Okay, so that gets rid of the single letter ones. Any other issues? Well, let's take a look deeper into this this list of words. So instead of looking at the first 50 things, let's look at, I don't know, 50,000 up to 50,050. These are more like the words that I'm interested in. They're, well, for one thing, they're not names. They're not acronyms. And so that's kind of good. And they're all lowercase. So what I don't like about those first 50 things, in fact, a lot of the beginning of the file is full of things like acronyms and proper names. And so a lot of people, would say, if you're doing words, proper names are not words, they're proper names. So let's get rid of those too. In fact, the clue here is if the thing starts with an uppercase letter, then it could be problematic for us. So let's get rid of everything that starts with an uppercase letter. And how do we do that? Well, again, we go to the internet and we say Python string case. Look for that. Oh, we see the string module has some common string operations. And we look for case in there. All right, some things that's not exciting, not exciting. Finally, we get deep down into this thing, and I'll tell you what we're looking for. Okay, some strings functions. We can capitalize words. We can do stuff, and it tells us there's something called string lower. Return a copy of the string with all the characters converted to lowercase. So why is that useful? Well, we're trying to get rid of things that have uppercase letters in them. So what should we keep then? Well, we should keep any word which is the same after we convert it to lowercase. So if we take our word and convert it to lowercase and we get exactly the same thing, then that means it was all lowercase to begin with. Those are the ones we want to keep. Okay, that's better. These look more like the things that I want. Okay, good. All right, so now we have a reasonable list of words to pick from. Thinking about features, what's the next feature we should add? Yep. There's also letters with accents. Yeah, let's leave those for now, because I don't want to figure out how to deal with them live in front of the class. Yeah. Yeah, so I won't worry too much about that yet, but I agree that the endings where they just add plural endings to things, that's kind of boring. Maybe we could consider filtering all of that stuff out too. But actually, we don't yet in this class know of an efficient way to deal with those yet, so I'll leave those there for now. So let's say that this is a good collection of words. We'll work with this for now until we see some problems. But what's the first feature of our game? I mean, in the description of the game, what's supposed to happen? Yeah. Okay. So the computer is supposed to randomly pick a word. Okay. Now we have to figure out how to randomly pick a word. Well, we saw that the random module has this rand range thing, which will give us a random integer, which we could use to pick an integer from the list, or we could or pick an index in the list, or we could go back to the Python random module documentation. And see that it has a function called choice. You give it a sequence, for example, this list of words, and it picks one random element from it. That's the thing that I want. I want to pick one of these random words. Okay? So now we'll say W equals random dot choice. Pick one random value from that list of words. And since we're using random now, we have to import it. Okay? And a little bit of debugging. We'll print W. Just to see if this is doing what it's supposed to do. Particularize. Buried. Toenail. Apotheosis. Entomologist. Programmable. Suggestions. Seems to be working. Oh, nice. Sorry. I really had no control over that. Okay, so it is indeed picking random words that are completely outside of my control. Okay, so, all right, so this thing picked a random word. Yep. Which one? This choice function? The choice function takes any sequence. So sequence can mean a lot of things, but for us, a list is an example of a sequence. So we give it a list, and it'll pick a random thing from that list. A range also is a sequence. So if I said take a choice from the range 1,000, then it'll really pick a random integer between 0 and 999. Okay, so what's the next feature of this thing we should implement? What's supposed to happen next in the game? Yep. Yeah, it's supposed to scramble the word. So I guess it should rearrange the letters in some way, right? Okay. So why not, I guess there's lots of ways we could rearrange letters, but scramble seems to mean like shuffle or mix up in some random way. So let's take a look at what the random module offers. And I've done this lots of times and I've seen lots of libraries. But so I know that there's something called random.shuffle. In fact, there it was, right after random.choice, that takes a list and randomly permutes it. Okay? So we have our sequence and randomly permutes it. So let's see if that will do what we want. So let's do a little quick bit of testing. So import random. And what if we say random.shuffle hello? So it says string object does not support item assignment. That's because you can't change strings. So instead of that, we should give it something we can change. And we know that it can change lists. So how do we turn our string into our list? Well, that we can do by saying for each character in the string S, we'll make a list that contains each character in the string S. Now we've got that. And if we random.shuffle it, then it seems to be shuffled. If I shuffle it again, I get something different. If I shuffle it again, I get something different. Okay? So this suggests we need to take W and make it into a list. And we say for C in W. And now we can random.shuffle WS. WS is supposed to be our word shuffled. Okay, so quickly test that. Okay, there's a list of letters. Seems to be working. Picking a random word and then randomly shuffling its letters. Now we'd like to present this to the user. So now we've gotten to the point where we can start the game, so we can say what the game is. So let's print a helpful message. Make these letters into a word. And I'll take my shuffled thing, which is an array of strings, and I'll join those separated by spaces, so I get something a bit nicer looking. All right. That looks good. Sometimes random things sometimes give you an actual word. And in this case, in that last example, we got what looks like an actual word. It's not clear if it's the original one or not. Okay, so next we want to ask the user to do this. So we don't just want to print this, but we want to make it an input. All right, make those letters into a word. And what you quickly realize is, yeah, this is a game that could get tricky after a while. Some of these words are long. So let's make our lives a little bit easier. And just for testing purposes, but also we can think of it later on as a way to control the difficulty level. Let's restrict ourselves to 4-letter words. What could go wrong there? Okay, so what do you think that is? That would be my guess. Okay, so we've gotten to the point where we're presenting the word, we're reading the word at random, we're scrambling it, showing it to the user, we're reading the user's guess. What's left to do? We should check if it's correct or not. So how do we check if it's correct? So there's an easy way to do that. I could say, well, the user made a guess, and I've got this word W that I chose. So if the guess is equal to W, then that's a correct guess. And otherwise we'll say it's incorrect. What do you think this is? I'm going to guess kilt. Correct. This one? Mime? Shout them out. No one wants to say it? Something sticky. No one has any problem saying that. Veil? Vial? Okay. Does anyone see a problem with what we're calling correct and what we're calling incorrect? So, what if someone gave us these 3 letters? What if that was the scrambled letters? Yeah. Yeah. So this could be 8, and it could be eat, or tea. So there's 3 possible answers there. Now, the computer has one answer in mind because it just picked some word and scrambled it, but that's not really fair, right? So we shouldn't be checking if the guess is equal to the thing the computer was thinking of. We should be checking if the guess is in the dictionary. Okay, so we should be a bit more careful there. Anybody know this one? It's only 4 letters. Surely we can figure it out. Lerp? I don't know. Wrong. This I would say is wrap. And I should change this message now because it's not necessarily exactly what the computer was thinking of. Anyone know this? Yep.
I just have a question on the condition you set for the one file.
Yep.
Every time you write the words equals square bracket something,
Yep.
are you just adding on more of the conditions?
No, I'm redefining what words is. Initially, words is the list of every single line in that file, each one being a string. Then on this next line, on the right side of the equality operator, I'm defining a new list. It's a new list that contains only the ones that don't have apostrophes in them. And then I'm saying, okay, well now this variable that I'm calling words, it refers to that list now, not the list of all these other things. And then in the next line, I'm taking the current value of words, which is a shorter list, and saying, well, now only include the ones whose length is bigger than or equal to 3. Give me a new list with those. And now this variable words refers to that new list, which is even shorter still. Okay? So words always refers to a list of words. It's just the list keeps changing. In fact, it keeps getting shorter and shorter. Okay. Yeah, I mean, I could have, this is the same, or I mean, it's basically the same thing as saying, okay, here's a new variable, words1, and now what's words2? Well, words2 is going to be all the things in words1, and so on. I mean, I could have given new variables there, but there's no need. This is, it's fine to, I mean, I'm not interested in the whole list, so why not just, it's gone. You know, after the first time I filter it, I don't care about the original list anymore. I only care about this new list, and so on. So at the end of this process, words is just a list of files or list of words, you know, that came. It's a sublist of the other stuff, but that doesn't matter how we got to there. It's just a list of words. Yeah. Yeah. So this is the syntax for this list comprehension that lets you do lots of nice things. We saw that it lets you do things like transformations to lists. So, for example, it helps if I'm actually in Python. List range 5. Okay, so now I've got a list with integers 0 through 4 in it. Okay, so the simplest thing you can do with a list comprehension is just get back the original list. That's something that looks like this. It says, give me a new list that contains the value x for every x that appears in the list A. So that's boring. That just gives you back a copy of the list. Now, you could also say something like, well, actually, what I want to do is, what I'd really like is x squared for every x that appears in the list A. And then I get something more interesting. Or, you know, x plus 2 for every x that appears in the list A. So you can do, this first thing can be any transformation of the things that appear, this variable that I'm using. So that's one way to use it. And you can, I mean, that's a way to use it. And you can also add conditions here, which is what I'm doing in this example up here. You could say, give me x for every value x that appears in A if some condition is true. Like, for example, if x is bigger than 0, then I get everything that's bigger than 0. Okay. And you can mix the two, for example, like this. Give me 1 over x for every x in A if x is bigger than 0, and that gives me 1, 1/2, 1/3, 1/4, and so on, because I'm only taking these things, and I'm taking 1 over each one. But in this case, we're doing a simple thing. We're just saying, give me every word W in that list if W is equal to itself lowercase, or if the length of W is bigger than 3, or if, and so on. Okay? So we'll finish up turning this into a game next class, and then we'll build a substantial game.